Fault finding in electrical circuits is one of the most important skills for anyone working with electricity, from beginners to experienced technicians. It is the process of identifying, diagnosing, and correcting problems within an electrical system. While it may seem intimidating at first, fault finding is essentially a logical and methodical approach to solving problems. With the right mindset, tools, and techniques, it becomes a structured process rather than guesswork. At its core, fault finding begins with understanding how a circuit is supposed to operate. Every electrical circuit is designed to perform a specific function, whether it is powering a light, running a motor, or controlling a system. Before attempting to fix anything, you must know what normal looks like. This includes knowing the voltage levels, current flow, and the path electricity takes through the circuit. Without this foundation, diagnosing faults becomes much harder because you have nothing to compare against. One of the most common approaches to fault finding is the divide and conquer method. Instead of checking every component randomly, you systematically narrow down the problem area. For example, if a circuit is not working, you might first check whether power is reaching the system. If power is present at the input but not at the output, you know the fault lies somewhere in between. By breaking the circuit into sections and testing each part, you can quickly locate the issue without wasting time. There are several types of faults that commonly occur in electrical circuits. Open circuits are one of the simplest and most frequent problems. This happens when there is a break in the circuit, preventing current from flowing. A broken wire, a faulty switch, or a loose connection can all cause an open circuit. In contrast, a short circuit occurs when electricity takes an unintended path with little or no resistance, often resulting in excessive current flow. Short circuits can be dangerous because they may cause overheating, damage components, or trip protective devices like circuit breakers. Another type of fault is a high resistance connection. This is often overlooked but can cause significant issues. Instead of completely stopping current flow, a high resistance fault restricts it, leading to poor performance, voltage drops, or overheating. Corroded terminals, loose connections, or damaged conductors are common causes. These faults can be tricky to identify because the circuit may still appear to be working, just not correctly. To effectively find faults, electricians rely on a range of tools. A multimeter is one of the most essential instruments. It can measure voltage, current, and resistance, allowing you to test different parts of a circuit. For example, checking voltage across components can help determine whether they are receiving power. Measuring resistance can reveal breaks in wires or faulty components. Continuity testing is particularly useful for identifying open circuits as it indicates whether a complete path exists. In addition to a multimeter, other tools such as clamp meters, insulation testers, and voltage testers can be used depending on the complexity of the system. However, tools alone are not enough. Knowing how and where to test is just as important. Random measurements without a clear plan can lead to confusion and misdiagnosis. A good technician always has a strategy before starting. Safety is a critical aspect of fault finding. Electrical systems can be dangerous, especially when working with live circuits. Whenever possible, power should be isolated before testing or repairs are carried out. Lockout and tagout procedures are often used in professional environments to ensure that circuits are not accidentally re-energized. Personal protective equipment, such as insulated gloves and safety glasses, should also be used when appropriate. Another important principle is observation. Many faults can be identified through careful inspection before any tools are used. Burn marks, unusual smells, discolored components, or loose wires can provide valuable clues. Listening can also help. Buzzing or humming sounds may indicate electrical issues. Experienced electricians often rely on these sensory cues to guide their troubleshooting process. Documentation and circuit diagrams play a significant role in fault finding. A wiring diagram shows how components are connected and helps you trace the flow of electricity. Without a diagram, you may spend unnecessary time trying to understand the circuit layout. When available, always refer to schematics to guide your testing and ensure accuracy. Patience and logical thinking are essential qualities in fault finding. It is easy to jump to conclusions or replace parts unnecessarily, but this can waste time and money. Instead, each step should be based on evidence gathered through testing. If a measurement does not match expectations, it provides a clue about where the fault might be. By following the evidence, you can arrive at the correct diagnosis more efficiently. Fault finding also improves with experience. The more circuits you work on, the more familiar you become with common problems and patterns. Over time, you develop an intuition that helps you identify faults more quickly. However, even experienced professionals rely on systematic methods rather than guesswork. In conclusion, fault finding in electrical circuits is a structured and essential skill that combines knowledge, tools, and logical thinking. By understanding how circuits work, using a methodical approach, and prioritizing safety, you can effectively diagnose and fix a wide range of electrical problems. Whether dealing with simple household wiring or complex industrial systems, the principles remain the same. With practice and patience, fault finding becomes not only manageable, but also a highly rewarding part of working with electricity.